Hey there, Math Hoppers. In this video lesson, we are going to review domain and range. So let's recall that the domain of a function or relation is defined as all of the possible x values. And I say relation and function. I know we normally deal with functions. We will see both in this video. So let's look at the graph of a common relation, and it is the graph of this circle. So when we are looking at the domain, we are concerned with the x values, and specifically, where do those x values begin and where do they end? So we want to look for the part of the graph farthest to the left and farthest to the right. When we do so, I can see that my x values coming in here from negative infinity, my x values start here at -4. Just picture that vertical line, x equals -4. That's the first place that we would hit the graph. So that point, -4, 1, we're concerned with because it tells us the domain x starts at -4. Now, what I'm going to do is I say picture a vertical line. I'm going to put a vertical line in, and as we travel from left to right, let's see where we stop hitting the graph. So as I travel, I'm still hitting the graph. As I move a little more, I'm still hitting the graph, so I'm still in the domain of the graph, right? Move a little more to the right, yep, I'm still crossing the graph. Move a little more to the right, still hitting it. A little more to the right, and there we are at the end. If I were to move this vertical line to the right anymore, I would no longer be hitting any portion of the graph. That tells me my domain ends at x equals 4, right? So my domain appears to be all of the values, all of the x values from -4 through 4. All right, well, we can express this interval from -4 through 4 in a few different ways. And actually, most commonly is going to be the first one we look at. It is called interval notation. If we use grouping symbols, it is known as interval notation. We either use hard brackets or soft parenthesis brackets. Hard brackets indicate that the values -4 and 4 are included in this graph. And we see that -4 is right on the circle and 4 is right on the circle. So we use hard brackets. This says -4 to 4 inclusive. That is my domain. The next notation is set notation. It looks a little scary. It's not as common. It's not that bad. It is read as x is a member of the set of real numbers. That's what this big funky capital R is, the set of real numbers anytime you see that, such that x is greater than or equal to -4 and less than or equal to +4. So that's it. It really is just interval notation with a little funky symbolism in front of it. All right, let's look at the range. So we'll use the same graph. The range is defined as all of the possible y values. And I want to look at the same exact graph. We're pretty comfortable with it. We've been looking at it already. Now remember, when we're looking at the range, we want to know where do the y values begin and end. You want to look for the highest and the lowest points on the graph when you're looking at the y values. So my lowest point appears to be down here at 0, -3. So my lowest y value is -3. We used a vertical line to kind of track our domain, so we're going to use a horizontal line to track our range. Remember, y equals -3 is a horizontal line. So as I move up from -3, I want to see, am I still crossing the graph? Am I still within the range of this graph? And I appear to be, as I move up, still there, until I finally get up to 0, 5. If I move this horizontal line further up anymore, I would no longer be touching the graph. So what that tells me is that my range includes all of the y values from -3 through 5. So let's use interval notation to say this. And the range is from -3 through 5 inclusive. Using set notation, looks exactly the same as it did, except it has y's where there used to be x's. Y is a member of the set of real numbers such that it is greater than or equal to -3 and less than or equal to 5. Okay, no problem. Let's look at the graph of a function now. All right, forgive my arrowheads. I had to make them up because Desmos won't let me add arrowheads to a graph. So looking at the domain, we need to look at those arrowheads specifically. We are very good at looking at arrowheads and knowing that it tells us the range goes on forever. But what we need to realize is if I came in from -infinity, this is not really the start of my graph. These arrowheads tell me that this graph is going to get wider and wider and wider gradually. it'll get wider and wider and wider to both the negative and the positive direction. So we need to get used to looking at arrowheads to tell us the graph will also get wider and wider in both the positive and the negative direction, telling us the domain is the set of all real numbers. So negative infinity to infinity. Notice there are soft brackets here. Infinity and negative infinity will always have soft brackets. Infinity is not a value. It cannot be included in our domain. All right, let's look at the range now. So for the range, we need to see the lowest point on the graph. I can see the lowest point on the graph is 0 and that it is included. There's not an open circle or anything like that. So the arrowheads, we're pretty good at this for range. The arrowheads tell us it continues infinitely upward from which point? From our lowest point 0, telling us that the range is the set of all real numbers from 0 to infinity. Notice 0 has a hard bracket. That is because 0 is a point on the graph. 0 is included in our range. And infinity, remember that never will get a hard bracket. All right, so let's determine the domain, of a really funky graph. Again, remember, the domain is the set of all x values for a function, and I'm going to hit you with this function. Probably haven't seen anything like this before. That's okay. So let's look at this point by point. Let's look at the domain first. All right, when we do that, this closed circle, this value at -3, -2, tells us that the x values start at and include -3. As I'm traveling from negative infinity, there's no arrowhead telling me this is going to get wider and wider and wider. It starts right here at -3. So my domain, the lowest value in my domain is -3. All right, but then I've got like a funky open circle here. The open circle at 0, 2 tells us 0 is not in this domain, because if I put 0 into the function, I do not return a value. If I returned a value, there'd be a solid line here. Because there's an open circle, that tells us you can put in 0, but you ain't getting anything out. So 0 is not in our domain. All right, let's travel further to the right. The arrowhead on the right side tells us the graph continues without bound, actually for both x and y, but remember for x it tells us it's getting wider and wider and wider. So what does this tell us? This tells us that the domain starts at -3. It goes from -3 to 0. It does not include 0. And then again, it goes from 0 to infinity, not including 0. And that is how we write that. We have this union symbol. It's like the domain has two parts. It goes from -3 to 0, but it doesn't include 0. But it continues past 0. So from 0 to infinity, it continues on, again, not including 0. All right, let's look at the range. And remember, I know it hasn't been that long, the range is a set of all y values for a function. Looking at the same exact graph, let's investigate the range. So let's start at the same point. That closed circle at -3, -2 tells us that the graph doesn't go below -2. So the lowest output, the lowest y value, is -2. Now let's go look at that open circle. That open circle at 0, 2 does not affect the range. I know, this drives everybody nuts. The fact that there's a hole here proves that the intended height of the function includes y equals 2. So I have no input here, but look at my output. The intended height of this function is clearly 2. So the open circle does not affect my range. Now, looking at the arrowhead on the right side of the graph, it tells us the graph continues without bound, so the range continues to infinity, giving me a range of -2 inclusive to infinity. And that right there, guys, is your review on domain and range. I know domain and range is kind of that stickler point where either you get it or you don't, and then it kind of always haunts you. So if you are going through these lessons, you should be subscribed to our YouTube channel. If you come to a question you cannot get, something about domain and range, something we've covered before, something we haven't even covered, send it to us. We will make you a custom video solution that will help you out. Until next time, Math Hoppers, take it easy.